Hello, good noon, I would say. Last session before lunch. I'll try to keep it brief. Anyway, the work is on GitHub. It's work in progress. It's a new topic for me. Mainly my background, I've been working in the industry, and occasionally I like to also write and try things. I'm mainly a Python user, Earth Engine user, etc. Big fan of open source. So this work is about road network characteristics and land surface temperature in two South Indian cities. Bangalore is the city where I live, and a topic which we all like is talk about the traffic and the roads, because we spend a lot of time on them. And since this is Python-based and the idea is to automate it, once you do it for one city, you can try it for another city. So this is briefly what I will cover. I'll not go into detail, but of that. The reason I wanted to look at it, like I said, I have been working a little bit on land surface temperature, and I felt that there was quite not so much research done, at least for India, on the road characteristics. An exception was for Ahmedabad, and they looked at MODIS data, so at I think the 1 kilometer resolution, and so for day and night, and at like road density. So the idea for this work is to extend to other cities, but not just to look at road density. There is a lot of data like OpenStreetMap available, and there are very nice contributions. So at the end, I'll tell you which packages also I used. Is to like this? Oh, okay, sorry. Oh, okay. Okay, maybe I'll try to. Thank you. Stand here. And, yeah, even I'm not used to it to stand, but it's okay. So what this does is to actually use the land surface temperature with Landsat data, and to automatically extract these road characteristics. To give you a heads up, they're basically, so in Python, you can do that. There are two wonderful packages. So since this is a free and open source conference, OSMNX is one, MumPy is another one, and so that was basically the idea. Like I said, literature, there is mixed results. I also have some mixed results, and yeah, so the analysis is done as of now at the ward level. I have at the end of the presentation something at the pixel level. So this is something that I've tried for one metric. So why do we look at ward level? In Bangalore, this unit is actually very important because a lot of decisions are happening at the ward level. So this is why, like I said, wanted as a start, look at ward level, because if you look at road density, you have to have it over an area. So this is, and there are 69 wards for Bangalore. For Chennai, there are 200 wards, so there's a hole there. This is, because this is not marked as a ward. This is actually a military area in Chennai. So the first thing, obviously, that had to be done is with the ward level data is to clean up the data. And there I try to use Python, but what you see if you go in the GeoPandas, it's not fully cleaned up. So a good way of doing it is to use QGIS and MapShaper. It's a wonderful cleanup that it does. So this was done before the data were taken in to Python. So the one hand, we have the land surface temperature. So Landsat 8 was used, summer months was used. I've not checked it with like winter months, etc. One thing that 3 different ways I have computed them, and this is done by another beautiful package by Professor, which you all could hear in the morning, Professor Xixing Wu, with GEE map. This was the package. So Landsat, you can compute this in different ways. One is you can take the band 10, the thermal band from the Landsat. One is there are lots of in the literature calculations, so you have to make some assumptions. And if you go through the code, you can see how I've done it. And then this was not done in Python. There are some Python this is a typo. This is done in Earth Engine itself. There's a package called Ermida. I know there are some implementations in Python, but I've not done that because this was just as a check. So like I said, everything in GMAP, cloud masking, etc. But the main results what are presented here is in the band 10, the thermal band 10, but code is there for the rest, and it is robust as well. So this is how it looks for Bangalore, and this is how it looks at the ward level. The temperatures, so here at the west side there is some like industries and all that. So I'll quickly go through this. So when you look at this, that work, like I said, like the work of Ahmedabad, rather than just saying, okay, let's only look at road characteristics, since we have the data of the Landsat available, you can easily do what I would like to call the usual suspects. So you can look at NDVI, your water indexes, building indexes, bare soil index, because this will give an idea. Then if you look at road characteristics, how important road is versus these usual suspects, if I would like to say. Again, this is computed at the Landsat level. So this is how it looks for Bangalore. I'm going to quickly go through this. This is how it looks for Chennai. And then the next step that I did was just a simple correlation. So you see in papers that they also do this first. And then a lot of papers just plot it. And so the NDVI, for instance, the R square is ranging from 0.27 to 0.14. Negative relationship, this is what we expect, but at least it gave me, okay, I think the computation on the LST was fine. Then this is this is for the water index, less relationship, so more for Chennai. There are a lot more water bodies for Chennai. What seemed to be the most, and this is very similar to other studies, is the building index. So this is a high correlation, statistically significant. And then bare soil index also as well. But now if we go to the road indices, so the Ahmedabad paper has looked at the road density. And one thing I forgot to tell at the beginning, so what they have done, they have digitized it. But if you, there is a package called OSMNX that automatically extracts the road characteristics for any place in the world. So the idea was here, rather than digitizing, this beautiful data is available and the frameworks as well to compute the road density in an automated way. Then other things, what I was doing, so this is some work that has been done for other cities, like for China it has been done, but as of, to my knowledge, for India I have not seen work on that. We're not going to go too much over the formulas, but straightness, it's like Euclidean distance versus the other distance, so between nodes and edges. The global closeness, so just it's like how close is your network, how close are the nodes one to each other. And local closeness means closeness within a radius. So I've taken 1 kilometer as the radius. As I said, I use the OSMNX. So instead of, if we have ward level data, instead of making a call 369 times for Bangalore, what I've done, I've taken the entire Bangalore and then did a truncate of this. Mostly I have in this work looked at all roads, but you can also say I only look at the drivable roads. Except for a few things in the study, it is fairly robust. So these are all things that in your program you can say, I want drivable roads, I want this, I want also service roads. Because in India, for just to give a small background, when I was new to the country, one thing that was surprising, people will drive also on service roads a lot. So there's also a lot of traffic. People will drive where there is place, and especially in Bangalore, people will drive. And then for these betweenness and the closeness parameters, I have used MomoPy package in Python. So this is OSMNX overlaid with the wards. On the right, these are just in the standard how you can actually make beautiful graphs in OSMNX. And this is the same for Chennai. So we have more road length in Bangalore. We have also bigger area, but we also have a more dense network in Bangalore than in Chennai. So these are at the ward level, the road indicators, the road density, straightness, global closeness, local closeness. And this is the same for Chennai. Again, I look at the correlation, and this is lower, but for some, than the other metrics like NDVI, NDBI, etc. But we can see some trends, mainly like for Chennai, the street density, and then also the closeness for Chennai, and for Bangalore, the straightness. So I've done here exactly the same. I've just given the plots. Interestingly, for Bangalore, when you do all roads and all drivable roads, so all roads is also private roads. So this takes everything that is in the database, from walkable roads, roads and park, everything, private, public, drivable. But if you go to the drivable roads, there is what you see that it is positive. So one reason could potentially be there's a lot of greenery intermixed in the first, if you take all the roads, because it's paths, etc. For Chennai, we see for both the roads a positive slope. So for Bangalore, there is some evidence, although very low, but it's statistically significant that a straightness of a road is having an impact, a negative impact on the land surface temperature. The idea is there is more air going. It's not so closed. So that's why the LST is down. So if the network is denser in terms of these nodes going down, we see also a positive relationship, what we expect. Like I said, again, the R squares are lower though, but there is some evidence. So some studies, as a study in the US, they didn't find any effect. The study of Ahmedabad had quite a good effect of the roads. So the last part is actually looking at the betweenness centrality. So what this is if a road is kind of crucial in terms of the flow, and I'll give an example after that, one would expect, so if the road is between nodes used a lot, so this is basically in words what betweenness means, we would expect that we have a higher land surface temperature. The problem is we cannot really look at this at a ward level. That doesn't really make much sense. So for this part of the study, what I've done for Bangalore, so this is in progress for Chennai, I've taken 3 wards together, and this is done with the pixel level analysis. This is one of the worst areas in Bangalore because the offices are located, and especially in the last 10 years, there's been extremely a lot of development. So I thought, let's maybe have a look at this particular area. So this is just some images. So what I have done here, I have taken the land surface temperature. Again, this is the band 10. So there were the blue, this is some lakes. And here, this is the road network. So where it's red means the betweenness centrality is high. So especially this road there, that's like a major bottleneck there. And also you can see the road there from north to south. That's like a road that a lot of people who come from the city want to go. So we see red means it is high, as we expect. So this is again overlaying the edge betweenness, so the street with the land surface temperature. So this is this between is raster. This is just some visualization. And then I extracted the pixels, the road pixels only from the LST. And here I plotted them. So there is a slight negative correlation, which we would not expect. But there was a paper, I think, from China, and they also had this negative sign. So this is still a little bit of a puzzle to me why we have there, although it's very little slope. So as expected, NDVI, the water indexes mostly explain the land surface temperature. To some extent, yes, the road characteristics matter, which is in line with the Ahmedabad. And in general, the results are quite robust, whether roads are only drivable or non-drivable, but I'm still doing some things, checks. So the next steps, so this was at the ward level. We can also do this, let's say at hexagons, pixels, we can all do this, this thing night and day, but we have to go at lower resolution. And differences, seasons, and yeah, so, and also things like traffic, that would obviously be very interesting to see how traffic would have an impact on that. But, so this is the code is there, and this is all the packages and what has been used in the open source. Thank you.
Okay, so we have some time for the question. Any question from the audience?